Okay, so we are going to practice with two-step problems with the single mole diagram. So we're going to start off with the moles of element two-step problems, and we're going to work number one out. So the problems say to convert to mass in grams. So in number one, we are given 6.02 times 10 to the 23rd atoms. So we're going to put question mark grams, and we are working with calcium. What we know about calcium is that we have that many atoms of calcium. Okay, so this is going to be a two-step because if we look at the mole diagram, we're starting down here in the bottom of atoms, on the bottom of your mole diagram, and we're going to go two moles, then we're going to go moles over to mass. So that's kind of our pathway. Notice there isn't a line going from particles or atoms to mass. So that's why this is a two-step problem. We're going to use Avogadro's number in our first equality for our problem when we convert over to moles. So if we want atoms to cancel, atoms will go in the bottom. And since we're going two moles, moles of calcium will go in the top. We're going to put a number one with our number of moles, and we'll put Avogadro's number here. Okay. Our next equality, now your atoms, they cancel out and we're to moles. So for your next equality, we're going to go moles to mass, okay? So if we want moles to cancel, moles will go in the bottom, and mass or grams will go in the top. And again, it's 1 mole. We go to our periodic table, we look up the mass of calcium, and that is 40 grams. Okay. Now, I know looking at this, your numbers will cancel out, but not all of them are going to cancel out for you. So I want to show you how you mathematically would calculate these. So you multiply everything on top, you multiply everything on bottom, and then divide. Okay, so we'll take 6.02 times 10 to the 23rd because if you look at number two and number three, we're not working with the same number here. Okay, so that's why I'm doing this. So we're going to do 6.02 times 10 to the 23rd times 1 times 40. So we end up with 2.4 times 10 to the 25th. Okay, so please make sure you're using your exponent button when you're doing this. And write that answer down. Then you're going to take everything on the bottom times each other. So that times 1 is itself. Okay, and then go on and divide. And we're going to end up with 40 grams of calcium. Okay. So number one is a model for 2 through 5. Let's take a look at number 6 now. So in number 6, we're given 540 grams of aluminum, and we want to convert this over to our number of particles or number of atoms. Okay, so we're going to put question mark atoms of aluminum, and we are given 540 grams of aluminum. Okay, so when I look at my mole diagram, I am starting here at mass, I'm going to go to moles, and then I go back down to our number of particles or atoms. So the first thing we're going to do is use our periodic table to find our mass to help us convert over to moles. So if we want grams of alumina cancel, remember grams will always go in the bottom. Moles, since that's where we're going to, will go in the top. Okay. Um, and it said go to your periodic table. So I look up the mass of aluminum and I round it. It is 27 grams. Okay. And I'm always going to put 1 mole there. So now your grams, they have canceled. If we want moles of aluminum to cancel, moles will go down here in the bottom. So now your moles will cancel. We look at our mole diagram. We're going moles back down to Avogadro's number or number of particles. So that's the number we're going to use in our equality. So the number 1 will always go here with our moles, and Avogadro's number will go up here. Okay, so we're going to multiply everything on top. So 540 times 1 times 6.02 times 10 to the 23rd. We get 3.25 times 10 to the 26th. We're going to take 27 times 1, which is 27. Now clear your calculator out, divide those two numbers. And you're going to get 1.25 times 10 to the 25th atoms of aluminum. So number 6 is going to be a model for 7 through 10. Again, with these, please make sure that you show your work. You're setting them up like how I'm setting them up. You're including your units and the substance in your problems that you're setting up. And then make sure that you label your answer. So 3 points each. Work, answer, label.